All right, folks, so it is 1:20 and we're gonna get started again. Hope you were able to get in a quick stretch break. I know it's no fun to sit all day, so, but so the second part of class, we're gonna start 5.4. We'll see how far we get today, and whatever we don't finish today, we will finish tomorrow, okay? But I think it's a nice way to solidify some of those equation solving skills that we started to try in 5.3, because now we're going to look at practicing more of those equations, and then a case of what happens if there's a whole bunch of logs in our equations. What's going to be different, okay? So I'm going to go ahead and share my screen. You can find the 5.4 notes in Canvas under the 5.4 page. All right, so 5.4 is a section called Properties of Logarithms. And in the previous chapter, we saw some properties that were handy, but what we're going to learn now is before we learn these properties, we're going to talk about why we need them, okay? Because there are situations where we don't need them, but I want us to understand when we need to use these properties and when we don't when we're solving equations, okay? All right, so let's start off with solving log equations. I know we didn't have that many examples in the previous lesson, so I want to make sure that this is something that we feel really good about, okay? Okay, so I put together some steps on how we can approach solving log equations. Now, number one is blank for a reason. So let's leave that blank. Make sure you leave a space for that if you're writing your notes separately. Okay, so number one, I don't know, let's come back to it. But number two, our goal is to isolate the log. So if you have a question that has one log, we want to isolate that log. So our base is going to be here. Our numbers on the other side. And then the thing that is being logged, the expression with x, that's right there in the green, okay? So step two is isolate the log so that it looks something like this. Log with a base, some expression with x in it equals a number. Your third step is where you rewrite the equation in exponential form. Meaning you go back to the base of a number, so base to an exponent equals that expression with x. And then our last step here is to isolate our x, okay? So the next few examples we're gonna see just require us to do steps 2, 3, and 4, all right? So isolate the log, rewrite the equation, isolate x. All right. So in this case, I look at this question and I see only one log. And I also notice that this log is already isolated. It's already by itself. So I can already skip step 2, all right? So step 2, where it said isolate the log, that's already done for me. I can actually start with step number 3 here. Rewrite the equation in exponential form, right? So we need to write our base raised to the number equals the expression with x. So let's color code before we move that slide too much more. My base, my number, and my expression with x, okay? So base, number, expression with x. And when I rewrite that in exponential form, it's gonna be the base raised to the power equals the expression with x, okay? So this is exactly what we did back in the previous lesson. We're just sort of really highlighting what those steps are, okay? I know that steps are really helpful as we learn new topics to kind of get us used to like the procedure of how we solve for things. Now, after we've rewritten it, our goal is to get x all by itself, all right? So let's go ahead and turn 3 to the 4th power into 81. So we have 81 equals 9x plus 2. What are the 2 steps that we need in order to get x to be isolated?
Subtract 2 and then divide by 9.
Perfect. So let's subtract 2 here. So we've got 79 equals 9x, and then we're going to divide by 9. And so we get x equals 79 over 9. Okay. Now for a question like this, I actually really prefer if you leave it as the fraction, okay? Another word for that is the exact answer, because like I said, a lot of times we end up with decimals, and every time we round, we end up getting a less and less exact answer, okay? So it is totally fine to leave your answer like this. And then because it's a log one, let's plug this number back into the original equation and make sure that we get a statement that is true. So log base 3 of 9 times 79 over 9 plus 2 equals 4. Okay, now let's take this step by step here. This 9 and this 9 reduced to 1, because 9 divided by 9 is 1. So I really have log base 3 of 79 plus 2 is 81. And if I think about what this means in exponential form, this is really saying 3 to the 4th power equals 81, and that is correct. So this is a true statement, okay? The other option you could have to check it is from here. You could type that into the calculator, log 81 divided by log 3, and you should get that equal to 4. Okay, so that's another way that you can check over that answer. So number 1 is a pretty baseline question that you have when you're looking at solving log equations. Only one log, it's already isolated, just have to rewrite it in exponential form and then check your answer. So let's take a look at number 2 here. All right, what's the same, what's different? What are your thoughts?
There's a base of 1.
There is no base written, so it is understood
as a base of 10
to be base 10. Okay, so now I tell you, I will write out that base, because if I don't, when I try and rewrite it in a log or in an exponential form, sometimes I'm like, what is the base? Okay, so I will to this day still write it out so that I prevent myself from making future mistakes. Okay, but now that we wrote in the base, this is pretty much the same setup as example number 1, right? We've already got our log isolated. There's only one of them. So our goal now is to rewrite it in exponential form. We have our number here. We have our expression with x here. And we have our base down here. So when we rewrite this, it's going to be 10 to the 2nd power equals 5x minus 11. Okay. That rewriting step is something that I want to be so solid for you that you just know how to do it. Okay. So definitely spend some time practicing that. From here, we have a pretty straightforward equation to solve. We can add 11. So I end up with 111 equals 5x. And then x equals 111 over 5. All right. And again, we can leave it in the exact form. It makes it exact, but it also makes it easier to check your answers. Okay. Because look at what happens. Just like last time, this 5 and that 5 goes away, but they might not have gone away so perfectly if you turned it into a decimal, okay? Now we have 111 minus 11, which gives me 100, equals 2. And if you just type log 100 into your calculator, you should get 2 as an answer. So that button on your calculator that doesn't have a base, it just has a log, that's the common log button. Okay. So very similar, but some small differences, like we want to make sure we know what our base is every single time. All right, so let's take a look at example number 3 here. 3, natural log of x minus 3 plus 4 equals 5. So if I think back to my steps from earlier, I want to make sure that I start with number 2, which is isolate my log. In other words, this, I want to get that expression all by itself on one side. So what do I need to move in order to achieve that?
You subtract the 4.
Perfect. So 3 ln x minus 3 equals 5 minus 4 is 1. Okay. And then we could divide by the 3. So in this case, we did have to do a little bit of algebra to isolate the log, all right? We didn't have to do that in example 1 and example 2, but that's sort of the level of isolating that you should expect, okay? Nothing too crazy, but just maybe add some things or subtract them or divide by something, okay? Now, because this is our first example with the natural log, I'm gonna rewrite it like this: log base e of x minus 3 equals 1/3. That way, I can tell that this is a base e. My number on the other side is 1/3. And my expression with x is x minus 3. So when I rewrite this in exponential form, I will get e to the 1/3 equals x minus 3. And from there, all I need to do is add 3 to isolate my x. X equals e to the 1/3 minus 3. And that is our answer.
I think it's +3, isn't it?
You're right, +3. It's been a long day. Thank you. Okay, so let's take this and check our answer now, okay? And it turns out that we're going to be able to use one of those properties we learned about in the last section. So first thing I'm going to do is plug in my new x. So 3 natural log of e to the 1/3 plus 3 minus 3 plus 4 equals 5. Now this plus 3 and minus 3, those go to 0, so I don't have to worry about them. So I really have 3 natural log of e to the 1/3 plus 4 equals 5. Now that property that we saw earlier says that if we have the base is the same as the base for the log, that it's going to equal whatever that power is. So really, this is saying 3 times 1/3 plus 4 equals 5, or 1 plus 4 equals 5, or 5 equals 5. And so the answer that we got is a solution. All right. Any questions so far about solving the equations? Okay. So let's take a look at a situation like this. Okay. So log base 8 of x plus log base 8 of x minus 12 equals 2. So take a moment, look at this equation. Think about what's similar and what's different from our previous equation.
The same base.
They have the same base. All right, that's a good start. Same base is important. What else? What might be similar or what's different from what we've seen?
You're adding the x and the x minus 12.
Yeah, you're adding those two different logs, right? Yeah. So in all the other questions that we've seen, we've only seen one log. And now, out of nowhere, we're seeing a situation where there's more than one log, okay? So here's the deal. This is going to require us to know step number 1 from those steps that we talked about earlier, okay? So there's something that we need to do, but our goal is to turn 2 logs by condensing them into a single log. Okay, so that's our goal. If we had a question that only had one log and only had a number and an expression with x, we could be able to solve it just like we did with examples 1, 2, and 3. Okay. So we're going to leave this question for right now. But when you look at these questions in general, right? So you're looking at all different kinds of log equations. I really want you to think, is there only one log? Okay, I know what to do. Or are there more than one logs and you have to condense them into a single log, okay? So that brings us to these properties of logarithms. We want to know how we can condense logs so that we can solve equations like we just saw, okay? All right, if you have your calculator, I'd like you to try a few numbers here. Okay. Try log 3, close that parentheses, plus log 5. And tell me what you get. Let's round to 3 decimal places.
1.176.
Perfect, that's what I got too. Okay, now I want you to type in this. And tell me what you get.
Same thing.
Same thing, okay. So I had a log of one number plus the log of another number, and we got a number. But it turns out we could get the same number by taking the log of the first number, not added, but times the second number. Okay. Let's try that one more time. Log 2 plus log 7. So log 2, close the parentheses, plus log 7 gives us about 1.146. And what should that be equal to?
Log 2 times 7.
2 times 7, good. And we could also say 14, right? 2 times 7. So this number is this number, and this number is this number, right? Okay, let's try another one. Log of 12 minus log of 2. And I'm getting about 3.585. Ideas on what we think could be another way to get that same number?
Division, 12 divided by 2.
Perfect. 12 divided by 2. Good. All right, so we've got our first number, which became our top number. And we've got this number being subtracted, which became the bottom number. Exactly. Okay. All right, one last one. Log of 2 to the third. Let's see what that equals. I'm getting 0.903. Okay. But I want you guys to type in this. And are you getting the same number?
Yes.
Yeah. So there are certain ways, and this is going to be true. So I just picked some random numbers. You can pick your own numbers, and this is always going to be true. Okay, so this idea that if you are adding 2 logs, it will turn into the same thing as condensing it into 1 log and multiplying those 2 things. That's always going to be true. If you have 2 logs and they are subtracting from each other, it will always be the same thing as if you condense it to 1 log and you divide. In this last case, if you have a log of something to a power, you can actually bring that power down as a coefficient, and that might help with some of the equation solving, okay? So the last thing we're going to talk about today is just give some do these rules, but with variables, so that you know that these rules are true no matter what the numbers are, okay? All right, so this first one right here is called the product property. And that says that if you have log base A of u times w, or 2 things times each other, you can expand it to be log base A of u plus log base A of w. All right, so you can read it this way. Oops. But the one thing about this is when we solve equations, we're usually going to be using it this way, okay? So if we have one log and we turn it into a lot of different logs, that is called expanding. But when we go in the other direction, we call that condensing. Okay. So let's write out one number example for ourselves. Log base 2 of 20. Can someone tell me another way that I could write that if I wanted to expand that logarithm?
Log base 2 to the 2 plus log base 2 times 10.
Perfect. Anybody else got another way?
Log base 2, 4, plus log base 2, 5.
Beautiful. All right. You could even do 1 times 20. That would be fine too. Okay, so there's more than one way to expand it, all right, with numbers. And so one thing I want us to just be really careful about, and somebody pointed this out earlier, which I love, all these bases have to be the same. If the bases are different, no go. We can't use these rules. Okay, so this base has to be the same as the bases on the other side. Right? What we're going to use more often than not is maybe something like this. So I'm asking you here not to expand, but to condense. So what's that going to be if we condense?
X plus 2 times x minus 3.
So we need a natural log of x plus 2 times x minus 3. And as kind of good practice for tomorrow, we could FOIL that out, right? And we would get x squared, because x times x is x squared, minus 3x plus 2x, so minus x. And then 2 times negative 3 gives me negative 6. Okay? So this expression is equal to this one. All right, let's take a look at that quotient property. Okay, so quotient property, as some of you already picked up on, is very similar to the product property, but instead of adding them, we're going to divide, or instead of adding them, we're going to subtract them. Okay, and so same thing, we can go this way, where we are expanding the log. Or we can go in the other direction where we condense them. But the condensing is what we tend to use when we're solving equations, okay? So let's do a couple examples with numbers in them. So let's say I had natural log of 5. How could I expand that into more than one log?
Would it be ln 3 minus ln 2? No.
Let's see. That would be, this would be the same thing as saying 3 divided by 2, right? Because in our equation, we're dividing those two numbers. And 3 divided by 2 is not going to give us 5.
It would be 10 and 2.
Yeah, you could do 10 and 2. I would totally buy that. All right. So natural log 10 minus natural log 2. Good. All right. Maybe you could also say natural log of 45 minus natural log of 9, because 45 divided by 9 gives you 5. Okay. So these are just a couple ways that you could get to that. But if we were condensing, which again, that's the skill we're going to use tomorrow when we solve equations, maybe I have natural log of 2x plus 10 minus natural log of 2. And if I were to condense this, I would get natural log of 2x plus 10 divided by 2. Or if you wanted to keep going, you could factor out that 2 from the top, cancel those out, and it could also be the same as natural log of x plus 5. So with the product property, and I'm going to scroll back up here for just a moment. For the product property, I think back to like when I first learned about multiplication, we used to write multiplication as an x, right? But when you turn the x a little bit, what do you get? Kind of looks like a plus sign. So in my head, that's how I think, like, okay, if it's multiplying the product property, that means I'm going to add a lot of logs together, right? And then I kind of use the same visual trick for my quotient property. I know that division looks like that, but if I take away the dots, it's a subtraction sign. So for the quotient property, I think, all right, this is division, but it's going to give me a subtraction on the other side. Okay. All right, let's do that last property, power property, and this will be the last thing we do today. So that power property says that if you have log of something raised to a power, that you can bring this power down to the front like a coefficient. Okay, so if I have log base 3 of 64, okay, I know that 64 is like 8 squared. So I could write this as 2 log base 3 of 8. Okay. Now, the same thing could be true if I have some variables. So if I have log of x minus 1 squared, what's another way I can write that that would not make me FOIL anything?
Log x squared minus log 2. I mean 2x? No, I'm confused. Never mind.
Okay, that's okay. I love the willingness to be vulnerable here. So we're going to take this power and we're just going to bring it right down to the front. Just like we took this power and we brought it right down to the front. So another way we could write this is 2 log of x minus 1. Okay.
So it doesn't matter if the exponent is on the outside or inside of the parentheses?
Ah, okay, I see where that comes from now. Yeah, so if we want to square the log, usually we would write it like this, like log of x minus 1 squared. So if we don't have that extra parentheses, then we're assuming the square only goes to that last part. Okay, so we've done a lot of stuff today. We've really hit the ground running these last 2 days, so I hope your brains are doing okay. But we're going to call it here for today. And this is good because we've gotten through a big chunk of this section. So I think review this stuff so that tomorrow when we pick up with like using this to solve equations, that it'll be fresh in your brains, okay? So solving equations is really the last section we have left before the end of the chapter, which I know is super quick. And then other than that, we will be ready for our exam on Monday, I think, I hope. All right, so I'm going to stop sharing my screen right now.